Forgot to do that. Doing it now. I hope the screen is visible to you, students. Is it visible?
Yes, sir.
Yeah. So yesterday we discussed about Kerberos, its application. I mean, what are the requirements for it and how to use it. Like in a in a workstation, basically, when you want to get service, a client wants to get service from a particular service server. So basically, what happens? Let me quickly give you a recap of it. So basically, what happens here? You have to go through Kerberos authentication server, that is here, which is comprised of an authentication server and a ticket granting server. Okay, for a client to reach the actual server, the main server, it needs to have uh, uh, service granting ticket. It needs to have a service granting ticket, and service granting ticket will be given or will be uh, given by TGS. Is that clear? That is ticket granting server. And for a client to reach ticket granting server, it needs to have a TGT, ticket granting ticket. Is that clear? So who will give the ticket granting ticket? That will be given by authentication server. Is that clear? So a client has to first send a request to authentication server, and from authentication server it has to get the ticket granting ticket, and from that, with the ticket granting ticket, it will request for TGS, that is ticket granting server, for a service granting ticket, and for that service granting ticket request, this TGS will give a service granting ticket, and with that service granting ticket it can directly communicate with the actual server. That is how the communication happens, and I have already told you how encryption, what keys are used, everything I have clearly told you. So this particular scenario is called as um, uh, Kerberos realm. Is that clear? Kerberos realm, you can make a note of it, students. Is a authentication process environment. Kerberos realm is an authentication process environment managed by one Kerberos server. Is that clear? So if you have only one Kerberos server, so this Kerberos server should be only one. Okay, and you can have multiple clients, multiple servers, but all those clients, to reach any kind of a server, it has to go through Kerberos server. Is that clear? And if in a particular environment, if there is only one Kerberos server, and that is called as a Kerberos realm. Is that clear? So Kerberos realm is an authentication process environment managed by one Kerberos server. Is that clear? So next thing is multi-Kerberos. What do you mean by multi-Kerberos? So, here the client, see, basically, let me put it in this way. Uh, okay, multi-Kerberos, you can make a note of it. Multi-Kerberos is a multiple number of such realms. Is that clear? Each managed by one Kerberos. Is that clear, students? So if you have an environment where you have more number of Kerberos realms, is that clear? So that is called as multi-Kerberos. That means this particular one environment is called as one realm. Like this, you have multiple Kerberos realms next to each other. Every Kerberos realm is managed by one Kerberos server. Is that clear? So that kind of a situation or scenario, you call it as multi-Kerberos. Is that clear? Now you may there might be scenarios where you are client from one particular realm and the service server from which you are expecting some service might be in another Kerberos realm. Is that clear? So that means your authentication should first happen with this Kerberos realm in its own Kerberos realm. It should have authentication with this Kerberos server, and then this Kerberos server has to give an authentication with a Kerberos server in other realm, and then your communication should happen. I have added a diagram for that. So just I want to know now, is it clear about Kerberos realm and multi-Kerberos, students? Is it clear? Am I audible? At least answer me whether you have understood Kerberos realms and multi-Kerberos or not.
Sir, in multi-Kerberos, there's only one server, sir, or or the whole architecture is repeated for multiple times.
A whole architecture is repeated for multiple times. That is multi-Kerberos. And the client might ask a service from another Kerberos realm. Here in this case, whatever we have studied, client is asking a request from the server in the same realm. In multi-Kerberos scenario, what happens? This client may request service from another server which is located in another realm. Is that clear? How the communication happens there? That's what we have to study now. Am I clear?
Yes.
Okay. So in that case, what might be the authentication procedure? Yes, this is the same diagram which I showed you yesterday. This is a detailed diagram where this has a simple timing diagram. So now, yeah, this is inter-realm authentication. That means you are communicating from one Kerberos server to another Kerberos server located in two different realms. You can see here client in realm A, Kerberos in realm A, Kerberos in realm B, and server in realm B. Okay, now this particular client A would like to get a service from this server which is in realm B. Is that clear? So now how the communication happens? This client sends a request for TGT, ticket granting ticket for local TGS. Is that clear? Ticket granting server, because initially for this client, this is the reachable Kerberos server, so it sends a request for TGT, ticket granting ticket. Is that clear? So for that, this Kerberos in your realm, in that client A's realm, will give a TGT, ticket granting ticket. Is that clear? Of for a local TGS. TGT for local TGS. Is that clear? So then what happens? It has the ticket granting ticket to reach the ticket granting server which is local. Is that clear of this? So for that, what client will do? Request TGT for remote TGS. Is that clear? So request ticket granting ticket for remote TGS. Remote TGS should be here. Is that clear? So now initially it sends a request for TGT for local TGS. TGT is ticket granting ticket. TGS is ticket granting server. So client will request for TGT with authentication server. Here authentication server will be there, which is not shown here. Okay. For that, this authentication server will give a ticket granting ticket to reach the local ticket granting server. So this local ticket granting server have the ability to give a ticket granting ticket for the remote Kerberos server. Is that clear? Ticket granting server. Is that clear? So for that, client has to request. Client will request for ticket granting ticket for remote TGS. That means other realm ticket granting server. So ticket granting ticket for remote TGS is given by again the local ticket granting server itself. So now this client have the ability or have the ticket, that is ticket granting ticket, to reach the remote TGS, ticket granting server. Is that clear? So with that, this client will request for service granting ticket for remote server. It sends a direct request to the ticket request for the ticket granting server from the other realm asking what it is asking for service granting ticket. Is that clear? Which is located in its realm. So by looking into that request, this remote TGS ticket granting server will grant a service granting ticket for that request. Is that clear? For this client. Then with that, it will do the normal communication with the service server located in other realm. Is it clear, students? Is this clear? Have any confusion here? You have to respond, students. My question is this multi-Kerberai or multi-realm authentication is clear to you? Yes or no? You have any questions?
No, sir.
Okay. So now I told you there are two versions, that is version 4 and version 5. So basically version 4 is Kerberos realm, a single realm we call it as version 4, and a version which supports multi Kerberai or inter realm authentication we call it as version 5. Just keep this in mind. Version 4 was supporting only one Kerberos realm, whereas version 5 supports multi Kerberos realm, or you can say inter realm. Is that clear? So that is supported by version 5. So that is about the Kerberos authentication procedure. So I want you to now make a note of the difference between Kerberos and SSL. SSL is also a kind of authentication mechanism. So I'm not going in depth towards SSL, but I just want you to know what is the difference between SSL and Kerberos. Is that clear? Please make these points, students. Okay, so please make a note of this. One side you can take, you can make two columns in a table. One is SSL and other one is Kerberos. SSL is a paid service. Is that clear? Please make a note of it. SSL is secure socket layer. SSL is secure socket layer. SSL is a paid service. Is that clear? Whereas Kerberos is free service. Please make a note of it. SSL is paid service and Kerberos is free service. Next, SSL uses public key encryption. Kerberos uses private key encryption. SSL uses public key encryption and Kerberos uses private key encryption. Okay, one more important point, note down. SSL, under SSL, certificates are stored under or certificates are stored at user machine's hard drive. Certificates are stored at user machine's hard drive. So what are certificates? I will let you know that. The next topic we are going to discuss about certificates only. Certificates are stored at user machine's hard drive, whereas in Kerberos, passwords are not stored. Is that clear? So there is no certificates when compared to Kerberos. So basically Kerberos deal with passwords that are not stored. Okay. So that's about the major differences between SSL and Kerberos. So with this knowledge, we will go ahead and see here in the slides whatever I have discussed yesterday and today. So how the Kerberos starts its communication, what are the notations here, ticket granting ticket, how it is, how ticket granting server will provide ticket granting ticket. All these points are listed out in this are there in this slides. So you can go through this for your understanding, but the diagram itself is sufficient for you to understand clearly. You should know the diagram properly, students. Okay. So this is about the Kerberos and Kerberos authentication system. There is one diagram of overview of Kerberos. You can see here what happens. User logs on in the first point. User logs on to workstation and requests service on the host. So what is second point? Authentication server verifies user access right in database, creates cricket ticket granting ticket and session key. Results are encrypted using key derived from the user passwords. So then that is sent actually. Okay. In third, again the same thing. Whatever I have discussed, it is clearly mentioned here. Just go through this diagram for a moment. Just see this diagram, all the points. Then we'll continue. Okay. So this diagram also will help you to understand the Kerberos system better, students. So as I said you, Kerberos, there are under Kerberos, there are two servers, authentication server and ticket granting server. And authentication server is associated with a database of all the clients. Is that clear? So distribution of public key, how a distribution of public key happens, that is also clearly given in this diagram. I want you to go through this, and we will be discussing this again later. Okay. So yeah, public key certificates. Yes, from here we are supposed to start again today. So what are public key certificates? So public key distribution scenario has drawbacks. A user must appeal to the authority for a public key of every other user that is wishes to, or that it wishes to contact. That means if I want to contact a particular user, I should request for the public key from the authority, from some authority. We will see who is that authority. Okay. Public key directory. So vulnerable to tampering. Yes. So if there is a public key directory, it may be vulnerable to tampering. Somebody may change it. Those problems will be there. Let us see what is the solution. So use certificates that can be used by participants to exchange keys without contacting a public key authority. Is that clear? In way that is reliable as if the keys were obtained directly from the public key authority. A certificate consists of a public key, an identifier of the key owner, and the whole block signed by a trusted third party. Is that clear? So there will be a trusted third party called as certificate authority. In short, it is called as CA. Keep that in mind. There will be a trusted third party called as certificate authority CA, who is going to sign every certificate, and that certificate will have the public key of a particular user and that particular user's identity also. Is that clear? So identity of the user and public key of it uh, will be signed by a trusted third party, and that trusted third party is certificate authority. Okay. You can ask who allocates or who give this um, right of certificate authority. So there are internet standards who select certificate authorities, and those certificate authorities will be given authority to sign a certificate and give it. Is that clear? A user can present her public key to the authority in a secure manner and obtain certificate. Then publish the certificate. Is that clear? So for example, if I have a certificate signed by a certificate authority, that is good enough for my communication. I can publish it to any other users around me. Is that clear? For communication. So that's how the public keys are shared. Your public keys are shared, whereas your private key is only for you and nobody can use it also. So requirements for certificate authority. In what might be the requirements for certificate authority? We'll see that any participant can read a certificate to determine the name and public key of certificate owner. Is that clear? So any participant can read a certificate to determine the name and public key of a certificate owner. Any participant can verify the certificate originated from the certificate authority and is not counterfeit. That means any participant, if say I receive a certificate of other person which will have the public key and its own identity, so user ID I can say, so I should be very much guaranteed that it is signed by a certificate authority and that is the right person to sign it. Is that clear? So that is should be another requirement of certificate authority. Only the certificate authority can create and update certificates. Very, very important, students. You may get a question. Who can create and updates the certificates of a user? Certificate authority can do it. Is that clear? So only the certificate authority can create and update certificates. A user cannot create a certificate. Is that clear? You have to give your public key and request the certificate authority to generate a certificate. So the certificate authority will generate it and give it to you. So okay, so I think these 3 points are important for you about the certificate authority. That is sufficient. So public key certificates. So the certificate authority, if A wants to have a certificate of its own, what A can do, A will give its public key to certificate authority. This certificate authority will clearly create a certificate and gives it to this A. Similarly, B also can get, and then this A and B can exchange their certificates among them. Is that clear? So basically, this is what the trusted third party we were discussing about when we started the initial discussion about our what I can say, Needham-Schroeder public key algorithm or approaches of authentication. We studied that time we discussed about in the presence of a trusted third party, without the presence of a trusted third party. We discussed, right? So that trusted third party is this certificate authority. So yes, that is about certificate authority. Now there is something called as directory services. We will see what are those directory services. So X.509 authentication services is also called as X.509 directory services. Is that clear? So what it is? It defines a framework for provision of authentication services by X.500 directory. It to its users. Is that clear? So serves as a repository of public key certificates. So if you want to contact a user, instead of contacting that user and getting their certificates, there is a directory where you will have all the certificates of many users. Is that clear? You can actually, when you receive your certificate from the from the certificate authority, you can actually place your certificate in the directory services. Is that clear? So those, if I want to contact you, instead of you asking you, I will directly go there and collect your certificate and encrypt the data using your public key and send or do something. Is that clear? So basically, your certificate should be available in the directory services. Each certificate contains the public key of the user and is signed with the private key of the trusted third party. Signed with the private key of the trusted third party. Very important. How do you confirm that it is a signature of the trusted third party? Only when it signs with a private key, because only he has its private key. Is that clear? Only trusted third party have its private key. So if a certificate is signed by a private key, it is very much sure for you that Yes, it is from the trusted third party itself. Also defines alternative authentication protocols. The format is used in SMIME, IP security, and SSL, TLS, and SET. All these formats we are going to study in this course. SMIME we are going to study, um, uh, which is basically email service. IP security we are going to study IPsec. SSL and TLS again security services. SCT secure electronic transaction. How when you do a online transaction using your credit card or debit card, how it works. So those things, even for those things, this certification authorities or directory services will work. Final version is released on 2000. So I think there might be new versions available now. So based on the use of PKC and digital signatures, the standard recommends RSA, which is an algorithm, and assume to require the use of hash function. So which we are not worried about much. What you have to understand is authentication services are basically, this is also termed as X.509 directory services. Okay, this is termed as X.509 directory services. That means all the certificates will be stored in its directory. It is basically a repository. Okay, so public key certificate use. So how does your public key certificate looks? You can see here Bob's ID information. So Bob's public key and CA information, signed certificate. This whole thing is a certificate. You have the user ID here. You have the user public key here and information about the certification authority who has signed it. And here it is the signature of it. Is that clear? So unsigned certificate contains user ID, user's public key. Is that clear? So uh, create signed digital certificates, use certificate to verify Bob's private key. You can actually take up unsigned certificate, uh, user ID contain sorry the user ID and public key. User ID and public key can put into a hash function. You can see here, where is it? Okay, you have Bob's ID, Bob's public key, and you can put it into a hash function. So when it is hashed, you will generate a hash code, and that is encrypted using the encrypt hash code with CA's private key for to form signature. Is that clear? That is how signatures are created here. So just go through this diagram when you are free students. You will clearly understand. So that's about public key certificates. So anybody can any user can have a certificate of its own signed by a certification authority. And what are certificates? It's heart of X.509 scheme in public key certificate associated with each other. These certificates are created by trusted certification authorities and placed in the directory. So X.509 is a directory. Okay, by CA or user. So who signs your certificates, or who creates and signs your certificate? It is CA. Who is going to place those certificates in directory services? Either CA themselves can place your certificates in the certification directory services, or yourself can place your certificates in the directory services. Directory servers itself is not responsible for the creation of public keys or for the certification function, merely provides an easily accessible location for users to obtain certificates. Is that clear? Directory servers itself is not responsible for creation of public keys or certificates. The only responsibility of these directory services is to provide a easy accessibility of those certificates. These certificates are created by certification authorities, students. Okay. Hmm. Figure 14.4a. So basically, next figure will have the image of a certificate, which includes the following elements. Version of the certificate differentiates among successive versions of the certificate format. Serial number unique within the issuing CA. So this is your X.5.9 certificate. Is that clear? So looks very big, looks complicated. Lot of things are there in it. Uh, So what will be there in it? You can see in a X.509 certificate. This is a revocation list. I will tell you what is revocation list later. Just don't worry about this revocation list now. So basically, in a X.509 certificate, a public key certificate, what will be there? Initially, a version, certificate serial number, then signature algorithm identifier, which algorithm you are using, what are the parameters, issuer name, that means the CA, certification authority, who is issuing the certificate, that's name of that. Then period of validity, for how much period you have. When you create a certificate, it is not for lifetime, there should be a validity of it. Then what is subject name will be there. Then subject secret key. So subject name will be basically the user, is that clear? Which user is using this certificate, that information will be there in the subject name. So subject's public key information, that means that user's public key should be there in the certificate, that will be there here. Algorithm parameters key. Issuer unique identifier. Issuer means your certification authority. So unique identifier, unique identification of the issuer will be there here. Then subject unique identifier, extensions, and finally signature. We will see all this in detail, like in the previous we saw for version and serial number. Next is signature algorithm identifier, algorithm used to sign the certificate together with any associated parameter, that will be there in this signature algorithm identifier. Okay. Then period of validity, 2 dates, the first and the last date on which certificate is valid. Subject name, subject's public key information, issuer unique identifier, subject unique identifier, extensions, signatures, covers all other fields of the certificate. Is that clear? So this is about the certificate. This is how your certificate looks. So what is a revocation list? So this revocation list will have all the certificates whose which are revoked. I mean those certificates which you cannot use. Is that clear? That will be there in the revocation list. So I will tell you exactly which type of certificates will be there in the revocation list. So user certificates may become invalid before they expire. Is that clear? Sometimes before expiring itself, the user certificates may become invalid. What might be the reason? There are three different reasons. You may take a note of it, students. Important, please note it down. The first reason is user's secret key is assumed to be compromised. That means you have the public key of the user. If the user's private key is compromised, then the certificate is no longer used, so it will be put into the revocation list. Then user is no longer certified by certification authority. Is that clear? If the user is no longer certified by certification authority, if the user goes under another certification authority, the previous certificate will become invalid. Is that clear? The third one is the CA's certificate assumed to be compromised. That means the CA itself, if it is compromised, then also this certificate issued by that particular CA is invalid. So these are the three reasons where your certificates are considered as revoked, and that will be placed in the revocation list. So that if a user sees any other user certificate in the revocation list, that means you should not actually trust that particular user. Is that clear? That's the meaning of it. So the expired, keep this in mind, expired certificates will not be there in the revocation list. Please keep this in mind. Expired certificates will not be there in the revocation list. So the time, the date and time will be updated and given to the user again. Is that clear? So that these are some of the things about certification authority, about certificates and your directory services. So we will stop here today. We have discussed about multi-Kerberai or inter realm authentication, and then we started with certificates. What are certificates? What will be there in the certificates? And then we discussed who signs that certificate, who creates that certificate. It is the certification authority. Then we discussed about directory services. X.509 is one directory service which is generally used. Okay, so that's all about today's topics. We'll continue in the next class, students. If you have any doubts, you can ask, or else you can leave.
Am I audible, sir?
Yeah, you're audible.
So when it is said that user secret key is compromised, that means uh, private key is kind of known to someone else. So
Yes,
like what?
yes, yes, you are right.
And if certification authority is compromised, means what does it mean, sir?
Certificate authority is involved with some other user and doing or involved in themselves in some malicious activities. That's the meaning
Okay,
of
okay. Thank you, sir.
it. Okay.